Hey guys, welcome to Algos and 10 Season 3, Episode 7, where I play a little bit of chess game for you guys. So I play a couple of chess moves to show you guys how this game works. Yes, that is a nice AI. So the game of chess has the following. It has the pieces of pawns, knights, bishops, rooks or castles, queens, and kings. For this episode tonight, we're going to code a function called canMoveTo, which is very important. And that is my chess game. No, I do not want to save this game. So yep, here's my episode for tonight. So obviously it's very important to know the game of chess really well. So ever since I graduated from Worcester Academy, did the sports camp and the Chinese school, I was always fascinated by intricacies of the game. And of course, this shout out to Magnus Carlsen, who is a grand chess master. As a computer scientist, I'm more intrigued by the algorithmic aspects and whether can we actually beat Magnus by predicting the moves like an AI bot would. So we're going to divide this episode based on the chess pieces, the pawn, the knight, bishop, rook, king, and queen. So essentially a six-parter episode with, of course, a seventh part being the test cases themselves. But as you know, code without test cases is like playing chess with only a king. So part one is the pawn. So in the game of chess, pawns can only move straight. Two spaces for opening, one space forward each for the rest of the game. As to capturing a piece diagonally. Implement a method called pawn can move to int x, int y, which determines whether a pawn can move to a coordinate in chess, rows A through H and columns 1 through 8 legally. For episode purposes, we can assume that the move does not mean that the pawn is captured, as will hold true for any of the other pieces. So I'm going to bring out my terminal and start coding the function. So vi pawn.java. So I'm going to make a very simple pawn class in Java, public class pawn, and then just very simple method, public void, public boolean can pawn can move to, got it, pawn can move to. So the beauty of these methods is that you can use basically the concept of inheritance from OOP. We can like basically inherit the different methods. So you have a public class chess, you have a class pawn. So this is a perfect pawn class, which is only one method for the pawn class, can move to. And we're going to basically copy this over once we have the rest of the class. So obviously, if x is greater than 8 and y is greater than 8, or x is less than 1 and y is less than 1, if this does not work, then you will need to actually say you cannot move this pawn there. So system.out.println illegal pawn move. Otherwise, you can do the following. You could do a for loop. For int index equal to 0, index actually equal to 2, because you could also subtract, you could also move forward by 1. Index equal to 2, index less than equal to 7, index plus plus. You do a for loop here, and you can now basically do the legal pawn move. So you could do x plus equal to 1. And since this is a Boolean, you need to return a couple of things. So once you have that print, it cannot work, you can return false. Otherwise, return true here. And there's your pawn method. That's it. So now I'm going to go to the more complicated knight method. So for the knight, you can move in an L-shaped direction. So you can implement a method called knight can move to int x, int y, which determines whether a knight can move to a coordinate in chess x, y legally. So this is a little more complicated, so I'm going to have to give a little bit of thought. So go back to our terminal coding. And make this a little bit bigger, obviously, because I want to code this thing a little more carefully. So I'm going to just copy the following. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 YY. And then make a new class here called knight. So add a little extra white line here so you can make a class knight. And now it's called knight can move to. So similar to the pawn, if the knight is not moved this way, you can move over here. Otherwise, you have to do a following. So this is where we get the L-shaped design. Since we didn't use index yet in the pawn move, we can actually now do it for the knight move instead. So for this one, you can do a legal pawn move with either. So now you have to choose a direction for it. So if the direction is going to be the following, you can have either it going to the left, to the right L, to the down L, or the up L. So you have 4 different directions to choose from. You can see how hard it's going to be to test case this thing if you don't use if you don't use inheritance. So if direction is left, then you have to change the coordinates to make the left L move. So you're going to do x plus equal to 2, and then y plus equal to 1. Else if direction equals right, you're going to actually do the opposite. Y plus equal 2 and x plus equal 1. Yes. And then another else if. So if you're going to have direction equals up, you can see it's a bit boring, but it's like generally how you want to move a knight. You want to do y minus equal 1. So you're going down, you're going up by 1. And then you do x plus equal to 2. And finally, else if direction equals down, you're going to move the knight down by 2. So y plus equal 1, x minus equal 2. And to make sure this actually makes sense, I'm going to do the following. I'm going to get a quick whiteboard to double check my work. So I'm going to get a quick whiteboard for this. So let's say I have a really simple L block shaped thing. So this is my first block. And this will be my second block. So this is just to like make sure my coordinates are good for the knight. This knight's the most unique. It's like basically moves in an L shape. So in that case, let's see. I have x equals 0, y equals 0 is my ordinate. So if I move the knight down here, that means I have to do x minus equal 2 and y plus equal 1. So I actually got it wrong because I have to redo it here. So I have to redo my knight here. So actually it's not going to be that x minus equal 2, y plus equal 1. And then y plus equals 2, x minus equal 1. And then y minus equal 1, x minus equal 2, and y minus equal 2, x minus equal 1. There you go. That's how you do it right. So yes, you have to be very careful with the coordinates when you're moving on pieces here. I'm actually going to rename this. So I'm going to just name this chess.java instead. That way it's nice and easy. So you can see that the knight and the pawn class are pretty similar. All right, moving on to the episode. We're going to now have the bishop. So the bishop can move diagonally in any direction. So this is almost like the interview question of like number of islands. So you have to worry about x plus equal 1, x minus equal 1, you know, the diagonal direction. So implement a method called bishop can move to xy, which determines if whether a bishop can move to a coordinate in chess xy legally. So let me pull up the terminal again, and this gets interesting. So I'm going to copy over the pawn method again, 11yy, and then, you know, put this thing here. And now it's going to be called class bishop. So for the bishop, it's actually much more straightforward than the knight because it's fairly easy. It's just diagonals, really. Yeah, bishop can move too. So once again, if the coordinates are wrong, just do illegal bishop move and return false. And then for all this stuff, you can do the legal bishop move. And I'm gonna actually name this legal knight move here, just to make sure my comments aren't screwed up. So how did I get involved in the game of chess when I was younger? It just came down to really learning about strategy games, learning about different types of like other things, really. So now you have another direction for bishop. You have two directions of bishop. You could either do positive horizontal and negative horizontal for bishop. So once again, I have to check for direction. If the direction equals positive horizontal, and of course, it's all pseudocode. It's not really compiling code, but it's a good way to think about the algorithm. Once I have the solution, I'll post it on the actual algorithm 10 for the real working version of the code. So this is just if direction equals positive differential. I didn't do the following. I basically make the bishop go diagonally. So I'm going to first save a little bit of this and show you guys what I mean by that. So I go back to my whiteboard and I can show you what I mean by that. So for bishop, if I were to go this way, I basically do the following. I do x plus equal 1, y plus equal 1. There you go. That's how you do it diagonally. Now if I go it this way, the other way around, I'm going to use the color blue here. Sorry, I'm going to use the color blue here. Select this thing, make it blue. Huh. Okay, weird. I'm trying to figure out what's going on here. Oh, I see. So yeah, make it this way, blue over the red. If I go down here, I then have to do the following. So I have to do x minus equal 1, y minus equal 1. So it's going down sideways in terms of that. It's really basic coordinate geometry more than anything, really. So I'm going to go back to my code and show you how the bishop works. So for the bishop, it's really simple. If it's, you know, going positive horizontal, going up, I do x plus equal 1 and then y plus equal 1. Otherwise, if it's going negative horizontal, and since this is going to be any valid move for the bishop, from index 2 to 7. That's not going to matter whether the bishop starts from left to right or right to left. If it's like another game like Weiqi or Go or more complicated Chinese chess, then we have a little more interesting stuff to deal with. All right, so far it's been pretty easy, pretty straightforward. Now it gets to the tough part, the queen. So I'm going to show you guys what the queen generally does, which is nearly everything. So actually, no, not yet the queen. I have the rook. So the rook is actually the easiest because it can only go horizontally, vertically. It can't do diagonals. So that's actually rather easy. So the rook and castle can move in a straight line, vertically, horizontally, any spaces from 1 to 8. Implement a method called rook can move xy, which determines whether a rook or castle can move to a coordinate in chess xy legally. So in this case, I'm going to make the rook method here. So I'm going to just copy the bishop method. See how many lines this is going to be. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, 18 lines. That's quite a bit. 18 YY P. I have to change the comment here. Legal rook move. So you can see inheritance is super important. Like if you don't have inheritance, this problem set would not go well for you. Because every single piece is so similar. So this is once again positive and negative differential. So if it's positive, it can only go positive horizontal. So you actually have two ways of doing it. You can have positive horizontal, negative horizontal, positive vertical, and negative vertical. So really it just comes down to what type of direction you really want for your rook. So if it's of course positive horizontal, you always just simply push it over to the left. If it's negative horizontal, you push it over to the right. So x and y do not change here. Now, if you want to make it positive vertical, you put the y up by 1. You can see this is very important to understand what's the difference between the chess pieces here. So y plus equal 1. Otherwise, you do x minus equal 1. So else if direction equals negative vertical, whoops, actually horizontal should always be x's. My apologies. This is gonna be y's. So you need to be very careful with like how the different directions go in chess. Otherwise, it is going to be a mess to code. It's a good interview problem. I think Gail's done exactly justice with this type of problem. It's not only a good problem for chess enthusiasts, it makes you think about coordinates, which is something that's very important in like Java graphics. So a really cool project for someone would be to like make a graphical version of a chess game, really. That's actually pretty cool. So anyway, that is my rook can move. So let me just quickly get to the bottom line of this code and change it up, and then we'll finally get to the queen. So I'm gonna just change it up to rook can move too. So another beauty of inheritance is you guys just change the different types of move for the chess pieces. And be careful, don't forget this thing over here. Finally, we're gonna get to the queen. So we're going to share screen and go for the queen. The queen will take a little bit of time, so I have to think about this for a sec. So the queen, she's the most important piece outside of a king. You cannot forget about the queen. In fact, she's so famous in the world of chess algorithms, there's an interview problem called 8 queens. So if you look at the 8 queens puzzle, it's very important. That'll actually be one of the problems I would have done for Algos in 10 had I had more time in the summer. And it's also one of the harder problems in interview as well. So the queen has pretty unlimited powers. She can move horizontally, vertically, diagonally, any way she wants from 1 to 8. Implement a method called queen can move to int x, int y, which determines whether a queen can move to a coordinate in chess xy legally. So you can imagine, since the queen is sort of moving like a compass, north, east, south, and west, and then with intermediate directions, northwest, northeast, southeast, southwest, you're going to need 8 different cases here. So to make life super, super easy, we're going to do the following for the queen. So we're actually going to copy the bishop. Actually, no, we're actually going to copy the bishop instead. Yeah, we're copying the bishop. So first of all, we're going to actually copy the bishop. We're going to name this class rook. There you go. So we're going to copy the bishop. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, 19 YY. So you can see this episode doesn't have any Kubernetes because it's really hard to make a Kubernetes with chess. But there's one way you can do it though. You can do it with Kubernetes multi-container with some chess, or even do a secrets. Like a move to checkmate Magnus Carlsen, or you can even make a services HTTP get and post. Like a AI version of chess, like one over here, basically. So you can do many things. You can do many things with chess and different types of stuff. But one thing you absolutely cannot do is make illegal moves. So we're going to have to make sure the queen can move legally here. So it's really a lot of repetitive but important code. So here we're going to do the following. We're going to increase this by having all the coordinates. So positive vertical, negative vertical, and then finally positive diagonal and negative diagonal. There you go, 6 different directions. So the queen is pretty obviously these two. So we're going to do the following. 1, 2, 3, 4, 5, 6. 6 YY and then P. So then we're going to change it up to positive vertical. So if the queen's going positive vertical, you can pretty much assume that's going to always be this. So because the queen is going positive vertical in this case, you don't really need to worry about it. You can just do the following. So if positive vertical is always going to be x plus equal to 1. If the queen's always moving positive, horizontal, sorry. If it's negative, you always do x minus equal to 1. It gets tricky with the diagonal situation. So if it's positive vertical, you do y plus equal to 1. If it's negative vertical, you do y minus equal to 1. That's pretty straightforward so far for the queen. It's been like sort of like the rook. It gets tricky with the diagonal case. So you have to think carefully about diagonal case here. So I'm going to do the following. 1, 2, 3, 4. 4 YY, and then right before return true, go here. I messed up. I screwed up the brackets. My bad. Okay, there we go. I almost screwed up the brackets. So now if it's going to be positive diagonal, you have to think carefully about this. So it's like the bishop here. So this is where you get to reuse a little bit of code. So for positive diagonal, it's always going to be x plus equal to 1. And because the queen can move anywhere from, up and down, we can do the following now instead. We can do the following. So x plus equal to 1 in general, and then y plus equal to 1 in general. We can do another if statement. If index less than, and the difference you can do is 5, so the queen can move only up. Wait, let me actually make it easier than this. Sorry. So index is basically determining how much the king and queen can move. So I actually have to redo the entire design here. My apologies. So it's actually x plus equal not to 1, to index, actually. X plus equal to index. That's what I was getting wrong. Rook, same thing, index, not 1. 1 is definitely the king instead, which is the last and most important piece. You have to be careful what you're doing in chess here. And then this is gonna be index now, not plus equal to 1. Actually, this would be helpful for the king though. So I basically already solved the king's problem for me. Because basic king is like a more newbie version of the queen, essentially. In this case, the queen, since you can move anywhere, you can start from index equal to 1 instead. And same thing for the rook. You can start from index 1 instead of index 0, of index 2. And this could start index 1 instead. So you could all actually basically start from index 1 for all of these pieces now. So I'm redesigning the entire algorithm to be a little easier to read. There we go. So index 1 is now where you start with all the pieces instead. So back to the queen. We're almost done with the queen, don't worry. So if direction is positive vertical, is positive diagonal, we could do x plus equal index, y plus equal index. And finally, else if direction equals negative diagonal, you can just see basically do the same thing they did with the opposite, x minus equal index, and then y minus equal index. Phew, there we go. There is the queen. Finally, we could do the king. The king's most important. If you have the king dead, it's checkmate, game over, you lose the game. So king is very important. If the king gets checkmated, you lose the game. Or in a rare case, the two kings face each other and nobody can make a legal move, ends up in a stalemate, which is a draw. So the king can only move one space horizontally, vertically, and diagonally any way he wants. Implement a method called king can move to int x, int y, which determines whether a king can move to a coordinate in chess xy legally. So let's wrap it up with the king then and do some very basic test cases. So we'll go back here and now we're just going to copy over for the king. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 29, 28, 30, 31, 32. Wow. King is getting rich here. 32 lines of code. Well, he's the king. He's supposed to be rich. And the king is super easy to fix, really. It's just change everything plus equal to 1. So class king, first of all. So this illegal, this would be king can move to. An illegal king move here. And then this is legal king move. So it really just comes down to refactoring. So instead of just retyping everything, I'm going to do the following. I'm going to just do CW1. And that's like a quick way to change word in Vim is to change word by 1. So CW1, 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 CW1. Be careful, however, you don't change the wrong space. And here I'm just gonna make it easy, 1 and 1. Well, there you have it. There's your general cases. So now I'm going to give a quick demonstration of how to do unit testing. I'm not going to write the unit test code here, just write pseudocode to give a quick demonstration of that. So for unit testing, we really want to do the following. You want to be able to make sure you have the right unit test. So what are you unit testing for? You're trying to test for the general case. Like, let's say every piece can only move by 1. Then you're going to test for a more specific case, which means piece by piece. And then finally, the unusual cases, which means like if another piece blocks a corner, pieces block each other, like in a real chess game. So really, unit testing could be quite simple in this case. So I'll show you a couple of examples how I would unit test this thing. So let me wrap up the episode with the unit test. So I'm going to add in a main function here. Public static void main string args. All right, let me make a very simple thing. So first make a pawn class object. So for example, pawn equals new pawn. And since we haven't initiated any of them, we're just going to do initiated constructor here. So we're going to do initiate constructor for each of the classes to make sure this OOP actually works. So I'm going to just scroll all the way up for the pawn. O here, public pawn. And it's like a wicked simple constructor here. That's it. Return. So just going to keep copying this piece of code to everything. So YY P, and this is a knight. So this is a knight constructor. Because this constructor is so easy, you don't have to worry about like calling anything really. Then P again, bishop, and this will do return. If you don't have the return statement, Java will complain it doesn't compile. So rook, public rook will also return. And finally, queen and king will also return here as well. So queen will return, and then king will return. So now you can finally do some easy test cases. For example, pawn equals new pawn, and then because this is in Java, we do assert equal. So assert equal. This is all pseudocode, by the way. So we're all assuming already you've imported the static void arg main. So let me first set number, go back to top of this thing. Of course, be careful with typos here. You know, don't mess up the typos. Import java.util.star, import junit.star. This is assuming you've already imported everything in your Java class. Let me just go back to the end of this thing. And it can now go back to here, assert equals pawn can move to, and we can have basically string coordinates. So for example, if we move to like space 2, E, and then comma, true, this should pass. Otherwise, if you want to make an illegal case, 2YY P, pawn equals pawn 2, so new pawn, so pawn 2 dot pawn can move to, let's for example 2 comma Z, it should be false. So this should fail. And you see, that's basically how you do a very basic unit test. You could do the same thing for everybody else. You could do, for example, 2YY. No, I don't want to do queen yet. Let me just do bishop, something a little bit easier. Bishop, new bishop. So a bishop cannot already move to its own space, so this should fail. So assert equal bishop can move to, it cannot move already from the space it began, 1, 1. So that should equal to false, and this should also fail. And there you have it for the episode. There you have it. Algos and 10, season 3, episode 7 with Jason Liu. Next week's my birthday, and of course, to celebrate the MasterChef amazing cooking show, we're gonna have Master App. See you then. Have a good night.